Hi, bro.
Hi.
Yeah. Once you record, you can share it in WhatsApp, right?
Yeah, I was there.
Yeah. Okay, bro. You do it once. Like we will see.
Sunil has not joined it right now.
Yeah.
You shared with link
Ah,
with him,
yeah,
right?
yeah.
Wait a few seconds.
Oh, you. Oh, I didn't share. I didn't share. I'll share. I'll
Okay,
share.
let's share with him also.
Bro, you are from Uttar Pradesh.
Yeah, yeah.
I'm from Kerala. Ah, I told you that.
Okay. Okay. Can you guys see my screen, right?
Yes, yes.
Okay. So we have fill in the missing values for all the columns, right?
Ah.
For all the numerical
Mm-hmm.
columns, right?
Yeah,
So,
yeah.
but there are like categorical columns as well, right? So
Ah.
one method to like regression always works between numerical columns, right? Uh, we have to convert these categorical column into numerical columns, right? One way is doing like
Ah.
encoding. So
Ah.
like if the data categorical data can be two types, right? Ordinal or nominal.
Mm.
So if the data is nominal,
Mm.
uh, then we will like do how many of the data is, if it's greater than 15, right, we will discard that column. Like let's see brand name, right? Brand name has like more than 15 categorical values, like, so in the regression
Mm.
analysis we will not use these like this column brand name, like we will delete this
Ah.
column A. So I'm
Okay.
going to go ahead and delete this, right?
Ah. Ah.
So then there is iOS, right?
Yeah.
iOS has like four values. So
Ah.
uh, we will create like numerical columns for it.
Ah.
And then there is a screen size is numerical column. And for like here, see 4G, yes and no. These are like ordinal data, yes and no, 0 and 1. We will for yes, we will replace it with 1, and for no, we will replace it with 0, right? Same with 5G,
Ah.
right?
I
So
didn't understood why like for S we replace it one like it is a ruler.
yeah, yeah, like let's say there is like ordinal data, right?
Uh,
And
Bro,
ordinal,
what is the difference between nominal and ordinal?
uh, for simple, this is, let's see, there is a sports team, right?
Ah,
So there is jersey number of every
yeah.
person, right? So these
Okay.
number does not represent anything, right? So on
Ah,
some person there is 33, there is 18, there is 7. It
yeah,
does not mean a
yeah,
team is greater player than 7. Like this is nominal data. We are
yeah.
assigning numbers just to distinguish the players, right?
Ah, yeah.
These number does not have any meaning. So
Ah, yeah.
in ordinal, like ordinal in like it has meaning, right? So let's
Ah,
say first rank, second rank, and third rank, right?
ah,
So
yeah. It has meaning.
so these first, second, third does not mean like there is a this margin of victory between first, second, and same margin of victory between second and third. But it means like
Yeah.
but it has order like first, second, third.
Ah,
So this is order. So yes and
ah,
no can be ordered, right? Zero and with
yeah.
0 and 1.
Ah,
Same cannot be said with like Android, like, oh yes, there's Android, Windows, others are like, this is, you're not create an order between them, between order Android and iOS and Windows, right? So
yeah,
it
yeah.
is, OS is nominal data, and 5 in 4G is ordered data.
Ah, okay.
So for the ordered data, we will like replace, there is only two values, like we will replace yes with 1 and no with 0, right?
So one more thing like OS is what you told like ordinal
Nominal
data.
data.
Oh,
Yeah, yeah. Yeah,
nominal data.
because
It doesn't have any meaning.
yeah, it like you cannot create order between them, right?
Ah, yeah.
You cannot say Android is
Okay.
better than iOS. You cannot say Windows and so on, and you cannot
Yes, yes,
compare.
yes, yes.
You cannot create order
Yeah,
between them. That's why.
yeah.
So
Why you deleted the first row? Like it
because
has more. Uh,
yeah, because if it is nominal data and it is greater than 15 data
Okay.
data values. Like in brand name, there was like more than 15. Like there was a lot of
Uh,
brand names and all. So that's why I
uh,
deleted that
yeah,
whole
yeah,
column. So it cannot be included in regression analysis.
yeah. Okay, okay,
Yeah.
okay.
So that's why we did that.
Yeah.
So let me select 5G and no options, and we will equals to, for now we will do this, replace it with 0.
Okay.
So
Is that a rule?
no, I don't think so. But for yes and no, you can treat as a binary value, right? Yes and no is like a binary value, that's 0 and 1. Like you can do
Yeah.
that.
So for every time we will give for no 0 and for yes 1.
Yeah, yeah. If
Okay.
it's ordered,
Uh,
so I have just like replaced all the no with 0 in 5G, right? So and I will like clear the filter from 5G and select S
yes.
and replace it with ignoring the first one with alphabetical order. Like we will not create a column name starting with Android, right? We will create with
Yeah.
iOS, others, and Windows.
Okay.
So and assign the values
Because
like
Android is already there. That's why, like for
no,
Android,
no, no.
that column
We
is
will
there.
delete
Uh,
after the assigning these values. We will delete the OS column also.
okay. Okay.
Yeah, yeah.
Bro, like uh, that
What?
4G column, like why didn't you give 1
Okay,
to S?
I'm just giving it. I've given, it's not
Okay.
showing, right? Okay, I'm just giving it, right? Wait a
Okay,
second.
fine, fine, fine.
iOS, uh, others, and Windows.
I didn't get you why Android you are not giving.
For Android, like, see, the rule is, if like there is a n number of like
Uh,
data in nominal, like in this
uh,
case there is 4, right? So we will create n minus 1 column. So 4 minus 1, like 3. So
okay,
which one we will discard? The first one with the alphabetical order.
okay,
Android
okay,
comes
okay.
first.
One minute. Okay, first one. So the first one with alpha in alphabetic order, like we won't consider that, except that like we will
Yeah,
make columns for the remaining, right?
yeah, yeah.
Yeah. So, bro, for all the categorical columns, like uh, the columns which are like more than 15, like more than 15 different values are like uh,
Yeah, yeah. We will
stuffs
not
are there. Like,
we
okay,
will not
we
include
will
educational. We will
we
delete
will
that
delete
one
that.
column.
Other than that, what to like categorical columns are there? Like for those all, we need to like we need to exclude the first value without alphabet in
Yeah,
the
yeah,
first
yeah.
stuff. Like yeah, for
So
those all we need to make
for the less than 15 like data points, we
uh,
will have to create n minus 1, like n minus 1 columns.
okay,
We have to
okay,
like I have created columns right here.
yeah, yeah,
So and if it's 4, that's why I've discarded first one,
okay,
Android. So we will
okay, fine,
select from OS, like I will select Android only, right?
okay,
So here, like I have selected all the columns with Android. I have filtered it, right? In when OS is Android, I will put 0 in iOS,
uh,
0 in others,
uh,
0 is Windows.
uh,
Okay.
okay.
So, and after this, I will select iOS. Like, okay, I will select
Okay.
iOS. Then I have selected OS as iOS. In iOS, I will give it 1, and in others,
Uh,
0. In Windows, 0. The thing is, if
okay.
the filter is also matching with like column that I have created, then I will give 1 in that case.
Okay.
Otherwise, in other cases, we will give 0 and 0, right?
Okay. 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 So
Yeah,
those all which are matching with the filter, like we need to give one.
yeah, yeah.
Okay.
Double click is not working. So now I have selected Android ones. Now I
Uh,
will select others, right?
uh,
Uh, so in case of others, I will give 0 to iOS,
uh, one to others.
1 to others, and 0 to Windows.
Zero to others. I think you need to select independently. Ah, yeah, no.
And then we will select Windows last. So in this case, uh, 0 to iOS, 0 to others, and 1 to Windows. Okay. So I have so I'm gonna go ahead and delete this column. So I have now only numerical values. I have encoded the categorical data into numerical data, right? So I'm gonna go ahead and create a regression analysis out of it. And they're like what we are trying to do, like there is a in regression analysis there are like dependent variables and there is independent variables. The dependent variable is only one, right? So what we are
Yeah,
trying to predict, like in this case we are trying to predict like used price, like what would
yeah,
be used price, like, yeah. Okay,
yeah,
so this will be dependent variable, like predictor we also call it. And all the like columns up to a to O, we assign them in as a independent variable. Like in the
independent.
we will provide is a x value of x, and this will be our y.
Ah, okay.
So I'm go ahead create a regression analysis out of it, data analysis. Where is like option of
So price is a dependent variable.
what?
User price is a dependent variable.
What
Your
difference?
voice is breaking.
User price is the dependent variable or independent variable.
So used price is like dependent variable. It is depending
Dependent
upon
variable.
the iOS screen size 4G or not.
Okay.
Main camera is what.
So
So
so usually they will tell us
yeah,
which
yeah,
one is dependent or
yeah.
like
Like
uh,
usually the thing is, price, profits, these all things all depends on the features of the like
Huh.
whatever the company is, right? What they
Huh.
are doing. Let's say, and there was one also, there is the mileage car of the data that sir was doing, right? So
Huh.
car mileage depends on variety of like columns data, right? So
Huh.
what we're trying to study, that's like that would be our predictor, what we're trying to predict, what we are trying to, and what are the features that are affecting it. They would be like independent variable, like on these independent variables, the dependent variable what predictor is of like depending. So I'm go ahead like create a regression analysis.
So user price is also called predictor.
Yeah, yeah, yeah.
Yeah. Okay.
Dependent variable is also called predictor, like what we are trying to predict, like, so it's asking for input wide range, right? I'm
Yeah.
gonna like select this one, and an input X range it's asking, right? So I'm gonna select iOS up to new price. So uh, I'm gonna also want residuals. I want labels. I'm gonna go ahead create regression analysis. Okay, here it is. So here it is, right? So this is intercept, iOS, others, Windows, screen, 4G, 5G, main camera, all the like all ignore this intercept term, right? After that, iOS, others, Windows, up to new price, right? We will check. These are like our independent variables, and this is like p-value of those all things. P-value of iOS is like close to zero, e की power minus 17, like it's very close to zero. But
Yeah.
so p-value is, so the rule is, if p-value is greater than 0.05,
Huh.
if
Greater than
then
0.05.
what,
If p value greater than 0.05.
then we will ignore that column. It's not contributing in regression analysis.
Okay.
Yeah. So for others, right, p-value is 0.7.
Huh.
Same is the case with Windows, right?
Huh. Okay.
0.7.
So
Uh,
why p value we are considering here, bro? Uh,
so p-value is like sir does not provide explanation into it. He just
okay. Okay.
told that,
Only purpose is to find which factors we need to exclude, right? Like those are close to 0.05. Like we don't need to consider that.
yeah. So
Yeah.
see, so for like others, Windows, you can see
Hmm.
it's less than screen size is less than p-value is 0.05. For it's close to e की power minus 9, it's close to zero. It's also close to zero. For main camera, it's also close to zero. For selfie camera, it's also close to zero. It's also close to zero, e की power minus 10, e की power minus 22 for RAM. For battery, it is 0.6. It will be also
Huh.
discarded. For weight, right? Weight, it has like 0.14. So it
Huh.
will be also discarded. Release year is
Okay.
also close to zero, e की power minus 11, e की power minus 235. It's very close to zero, like day used. And for new price, it's zero, right? So we will go ahead, what four columns, like battery, weights, others, and Windows, right?
Huh. Okay. It
These,
should be p value should be less than 0.05.
yeah, yeah.
Okay. Okay. Uh, so which all we are considering here? Windows.
We are, these are insignificant. Windows,
Huh.
others is also insignificant. Windows is insignificant. Battery is also insignificant, and weight is also insignificant, right?
Yeah, these all are greater than 0.05.
Yeah. So
Yeah,
all
okay.
these,
So
yeah,
we
we
don't
will,
consider.
yeah, these are insignificant column, and we will go
Uh,
ahead and like delete these columns
okay.
and again do regression analysis. Okay. So like we have others, delete this one, Windows, delete this one. What others? Weight and battery, right?
Mm,
Weight
mm,
and battery.
yeah.
So we will delete this thing.
Okay then. Fine.
Yeah. It will hardly, if system was working, like it will hardly take 15 minutes.
Like, are you running Mac OS on virtual machine? Yeah.
No, no, bro.
But still, why it's getting hanged?
Yeah, no, I'm using like WinTrig package that let me like use Excel on Linux. You know, you cannot use Linux on here.
Okay.
That's yeah. So, so I'm gonna select labels. Residuals are also important. Yeah, new okay. Select okay. So let me save it once, like if something happens, you don't lose the file. Okay. So now we have done like analysis of after removing all the like insignificant columns, right? So the p-value is will not be greater than in any column 0.5. Like it's also close to zero. So every value has like this is also close to zero. Every value will be close to zero. It will be greater than 0.05. So we were doing model evaluation, right? Model fit is uh, seen by like r square value 0.94. It's greater than 0.6. For a model to be fit, it has to be r square value should be greater than 0.6, right? So we will gonna check like prediction accuracy of the model. Like prediction accuracy can be checked by RMSC value. Like so RMSC value. What RMSC stands for? Like root mean um, square error, right? Okay. So we will go backward from error square mean root, right? So what is error? Error is residual, right? What is like predicted price and what was actual price? So this is residual. That's why I see these are all the residuals. We will square that first, all the residual, because there is negative terms in it, so that they become positive. Then we will take the mean of all the squared residuals.
Okay.
And then after taking the mean, it will come one value. Then we will take root of that thing, root of the mean. So I'm gonna create a column like square of residuals. Okay. So I'm gonna put a formula here. What is that? Like SQRT of this thing, right? Do you wanna give
Right.
it?
I will ask you one thing. This accuracy, prediction accuracy, there are two factors, right? One is RMSE and the other is MA.
MAP. P.
Okay. MA, like we should find both, right? We should do both, right?
Yeah, first we will do RMSC, then we will
Okay. Okay.
go ahead with the MAP. Okay. So I'm gonna like square it, right? 2. Okay, so
Yeah.
no.
Just double tap.
Yeah. So this is the square of residuals. I'm gonna take the average of it, right? Mean. So what would we mean? I'm gonna equals to average of first number to let me just drag it down. This is the last number, right? When I hit enter, this is the mean, right? Mean is 784, like, and then we will go ahead and calculate the root of it, right? So root would be SQRT of this value. So it is 27 point this. So this is the RMSC value, but we can calculate the percentage RMSC value also. Like we will do max error. What is max
So
error?
I'll ask you one thing. Like first we did square, okay. Then we find out mean. Then again
Yeah.
we do square, huh?
No, we are taking a square root of it.
Square root, right? Okay.
Yeah.
SQRT.
Yeah.
Yeah.
So this is RMSC value, 27 point this value, right? So we can also know what is maximum error. For maximum error, right? So we will go in this column, right? Used price. Used price is our predictor, our dependent variable. Like if we calculate the average of dependent variable, right? So I'm gonna go ahead like calculate average of used. So it is maximum error, and if we divide RMSC value with maximum error, that will give percentage. It is 109.88, right? We will use that. So maximum error is here like 109.88, right?
Okay, the average of the predictor will be the maximum error.
It's like what dependent variable. It's see, don't confuse it between these two. Like, okay, I'm just gonna. The model has given the predicted used price, right? It's 93 for first.
Yeah.
Okay, so here it is 86. It is actual.
Okay.
Model has predicted 96, right?
Yeah.
Here it is like 216 for second column, but in here, right, it is 161. So this is how error is calculated, right? So you will use predicted used price minus of what? Actual used price, right?
Actually, okay.
If you subtract that, this is what residual is, right? 0.6 of difference. It has like difference of minus 54, right? So this is error. Like what is predicted, what is actual. This so this is error, and we have like square of error. Then we calculate mean, we calculate error, and this is maximum error. Like, so for RMS, what?
So maximum error, how we need to find out is like we need to take the
Average of
the
actual dependent variable.
Okay.
It's not for predicted. So RMSC percentage would be equal to this one, like root RMSE value divided by maximum error. We can like multiply by 100 for it for percentage term. So 100. What is
Like how to
there is typo in
what it
formula? Okay, okay. I have not given. Let me just. It's 25%, right? 20. If you
how did you
what
how did you find out this RMSC percentage?
root
Like
root divided by maximum error.
okay. Okay.
So here is a formula. Like let me just formula text to formula text. This self F35 divided by G35. I was like
Root divided by RMSC.
yeah
Yeah. Root divided by maximum.
maximum error. I was
Into 100.
multiplying by 100, right? Into yeah, this is 25% is RMSC value, right?
Okay.
Yeah.
Yeah.
So now we will calculate this is RMSC value. So if
Yeah.
RMSC value is greater than like 10%, it should be RMSC value should be less than 10%, right? To like better prediction. Like it is 25%. That means like model prediction is like way off. Like it's not making good predictions, right?
So RMSC should be less than 10%.
Yeah, around 10%. If it's like 11%, 12%, like we can manage, but like it's 25 way off. Like it's like 25% time it's making error. Like so it's like not making good predictions. That like this model is not making actual good predictions.
Okay.
So yeah,
So this part gonna fail, right?
yeah.
Okay. So if one is fail, like, is there any use of like finding the other factors, or we should
No,
stop it here itself?
no, both are like same thing, right?
Uh,
Yeah. So I'm gonna go ahead like hmm, predicted outcome. I'm gonna copy this residuals, right, and paste it in the used form for MAP calculation. It will okay. So residuals are here, right?
yeah.
So for MAP value, we will divide residuals by used price, right?
Okay.
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 So we will go ahead and like MAP. We will give it a name and what we'll do residuals uh, divided by used price,
Use
right?
price.
Yeah. So these are the values, right? So it is in
Yeah.
negative terms, right? Also, so we'll go ahead and take absolute of it, like remove the negative terms of it. Okay. So we will go ahead and like equals to ABS, use formula and this one and hit enter. So this is, let me just copy it here. We'll put it here. Okay, so we have taken absolute of it, right? So
Yeah. What is that value? 1.109.8.
that's like average of this value, used price that earlier we calculated, right?
Okay. Okay. Okay.
So I'm gonna go ahead like take a mean of it, right? So I'm gonna take mean of ABS, right? So okay, delete this one. Here I'm gonna mean of ABS. So it equals to, what is that? Average. Average of this.
Yes.
What is this value? This, right? So it is, and if I multiply it by 100, right, it will be 27%, 27, right? So this is the percentage of MAPE value. So MAPE actual value would be MAPE is like equals to this cell multiply by 100. So this is 27%. RMSE percentage was 25% and MAPE percentage is 27%, right? So what we did in MAP, take the residuals and divide the residuals by used price.
Used price, yeah.
And then
And take absolute.
yeah, then take absolute of it, and then we take the average of all the absolute values.
Okay.
Yeah, this is if you go through the formula, you will understand. Like this is a summation of yi minus y hat bar. That is like residuals that is divided by yi, like used price, earlier price, and we taking summation. Summation means like we can first we will take absolute value, then we take average, like summation of it divided by 1 by n. And
So what's the full form of MAP?
it's let me just write it. I will write it.
Leave. Leave.
Okay, so I have done RMSC value, I have done MAP value. They are not giving me good predictions, right? So the third thing is what we will check assumptions, like assumption check. First assumption is like residual means should be what? Zero. Yeah. So what we're gonna do like check for it, like okay. So average average of what? Residuals. I'm gonna go ahead drag it down to bottom. So here it is. It is close to e की power minus 13, right? It is very close to 0. So we will take residual mean is 0. First check is, and then second is residual should follow like normal probability curve, like normal like bell curve. Like for that thing we have to check like skewness of residual, right? Residual, if skewness is like greater than 0.5, then we say it's like not normally distributed. If like skewness is less, then we say like it's normally distributed, right?
Yeah.
So we'll
so first, so the okay. So the residual mean should be 0, right? Like for the first case. So we got 3 point. It's closely to 0. So we can
e की power minus
consider it,
13.
right? Yeah. So we can consider it, right?
Yeah, we can say e is very close to 0, right? 10 की power, it's 10 की power 13, like it's on like denominator, like it's very close to 0.
Yeah.
So we're gonna residuals, skewness of residuals, right? So I'm gonna, this is right, enter. So it's 2.39, okay? So skewness is higher, so it's residuals are not like residuals are not normally distributed. So third one is like we should check residual have constant variance, right? So for this case I cannot show you because you know in my Excel like I cannot draw graph. So what I can do is so I'm going to tell you how you see that. So we will draw graph between residuals and predicted value, right? So these two columns, predicted used price and residuals. If you I'm gonna just select these two and control
Like
C.
actually, why we are drawing graph of this predictor and
To see, and residual should have constant variance. So to check constant variance of graph, we will draw a scatter plot between predicted values and residuals. If there is no relationship between them, right? So if we cannot find any pattern between those scatter plot, we will say that there is it has like constant variance. If there is some pattern like it's like linearly going up, linearly going down, then we'll say like it has like some like not its variance is not constant. This is the logic. So we will go insert and recommended charts, right? So it will not draw in my Excel. So
okay.
Yeah.
Then so that is the last part.
Yeah, that is last part. So let me just show you like the thing I did, right? So yesterday, this is my okay. So let me just, this is okay. R square value is what? 0.94, right? So it's greater than 0.6, right? So model is fit. Model fit is good. RMSC value is 25% and MAP value is 27%. So they are not good predictor of the. So we can say they are not good fit. Assumption check is like residual mean is 0, right? So we can say like close to 0, so we can say it's fit. Residual skewness is 2.39, right? So it's not fit.
Yeah.
So residual variance can be like used. So it cannot be used because one of assumption is not working. It's not good predicting, so we cannot use in production environment, right?
Yeah. No, I will ask you one thing. If the show that file.
This one. This one. This one.
Yeah. No. Your file.
This one.
The one which you did. Yeah. Here. Okay. So since the skewness is not normally distributed, what I came to ask is like
no.
Fact like,
let me just explain. Skewness is greater than 0.5, so residual is not normally distributed.
Yeah, understood. What I'm asking is like we need to plot scatter plot, right? Like which all factors residual and
yes, we have to draw scatter plot between predicted use price and residual.
Okay, predicted use price and residual.
Yeah. So when you will draw the constant variance, so there is a term called homoscedasticity. So the residual should have constant variance. It has a term called homoscedasticity. So you can draw predicted use price and residuals. Whatever the predicted, in this case, it's predicted use price. In other regression analysis data set, it can be predicted anything. So it would be always between predicted outcomes and like residuals. What is the error? So when you draw that, so in this data set, when you draw the like scatter plot, there will be no relation. You will find no relationship between like these two. You cannot say like it's going downward, it's going upward. So so one way to visualize it here, like I have made correlation, right? Correlation. Let me just so I have done it or not. Okay.
What is the sheet 5 of yours?
Sheet 5. It's correlation. I have used correlation, I think.
Okay. We have to do correlation first?
No, you don't have to. I just use there's no need to do correlation. You do it once on your behalf. I think if you stuck somewhere, just let me know, right?
Yeah, sure.
Yeah.
That's all right.
Yeah. So I think it will like in 10 minutes will end, right?
So you understood everything. Do you have any question?
No, bro. If I get stuck, I will call you tomorrow. Like we'll meet tomorrow in college, right?
Yeah.
Sure.
So if you guys do today, if we will connect tomorrow, and you guys will share like your skin if there's you stuck somewhere. If you did it, all right.
Okay.
Okay.
Okay, bro.
Thank you,
Then
bro.
No
thank
problem.
you so much, Yash.
No problem, bro.
Thank you,
Yeah,
bro. Ish.
thank you.
Thank you. No problem.
Thank
Okay,
you.
bye.
Bye.
Bye.